This nth term test is one of the easiest tests that we're going to learn, all right? Here's how it works. If you do the limit as n approaches infinity of a sub n of the nth term, and the nth term is this formula part of your series, okay? If you do the limit as n approaches infinity of that, and if you get anything other than 0, that proves it diverges. That's it, all right? If you get that limit is equal to 0, that means that test is actually inconclusive. It would be nice if it just does both, right? It tells you converge or diverge, like that geometric series test told us one or the other. But if you do this limit and you get 0, that's inconclusive. Inconclusive means you don't know squat. You can't use the nth term test. You got to go back and choose something else. You don't know whether it converge or diverges. You just got to go back and choose a different test. It works really well when you have like rational functions like this with polynomials over polynomials, or even if you have square roots involved, things that we've done the limits of, if you could do that limit real quick, all right? So here's how it's gonna work there. I'm gonna do a limit as n approaches infinity of the original term. That's gonna be the original formula of the a sub n of that n over 2n plus 3. And then so I need to see this, okay? The limit as n approaches infinity of that. I need to see that. And then you can use your pre-cal shortcuts. You can use L'Hopital's rule if you want to, because you got infinity over infinity right there, but you're allowed to use your pre-cal shortcuts when you got the nice polynomials on the top and the bottom there. And so you can use the leading coefficients. That's gonna give you 1/2. So I need to see this, and then you can use your pre-cal shortcuts, give me that answer. And then since that is not equal to 0, so since this is not equal to 0, that proves that that series diverges. So I'm gonna write down diverge. And remember, you're always gonna tell me converge or diverge, and you're gonna write down the test that you're using. And so diverge is our answer, and we're using the nth term test. Couple things that people get deducted for as a turn this in. You need to write down what you're taking the limit of. Don't put n over 2n, don't put 1/2 right there. Don't use your pre-cal shortcuts yet. Tell me what you're taking the limit of, because we're gonna do several tests in the future that involve limits, and this won't always be the original function. This is gonna be something different in the future. So you can't just put down the limit is equal to 1/2. We don't know what you're talking about, all right? Also, don't make up your own names for these tests. This test is called the nth term test. Call it that, okay? Don't write down limit test. There is no such thing called a limit test because, like I just mentioned, there are several tests that we're going to use limits for that involve limits. There is no test called a limit test right there. So look how short and quick that is to write that down. So you're going to tell me converge or diverge, tell me the nth term test, and I need to see that right there. And then obviously we need to see what your answer is. So please model the notes there. Everything that you got written down there, that's what we need on those problems there. And I just want to mention that if you did plug in, notice you don't have like a number raised to the end, like on the geometric series test, to tell whether that's, you could probably know that's not geometric right away. Also, if you did plug in 1, plug in 2, plug in 3 for the ends, you're getting this string of numbers right there. And there is a pattern to that, but it's not geometric. You're not multiplying by the same thing each time, okay? But like I said, you pretty much will recognize a geometric series when you have a number raised to the end, and that's not a geometric series. That's why we're learning a bunch of different tests here, okay? Now, if like I said, if this was equal to 0 and not 1/2, then I can't use the nth term test. I'm gonna have to use something different right there. Also, when you mix them all up and put them all together, this is one of the tests that's basically at the top of my head, at the top of the chart. Like on an integral, you always look for that UDU first. If I see something like this, I always think the nth term test first, because if I do that limit in my head real quick, I know that answer is gonna be 1/2. I know that's not equal to 0, so I can put diverge down. So if that works, then I just have to write down a couple steps and then I'm done. But now, if I were to do that limit in my head and I get 0, then at least I checked within like 3 seconds. And then I said, okay, you know what? Not even 3 seconds. I would check in my head and I realized that, hey, if I got 0 for that, at least that didn't work. And I would go on to a different tester. But you don't really want to skip over that easy test when it does work for you. But I just want to mention, again, that only proves divergence. You can't ever prove convergence with the nth term test. It only proves diverge.